Dear viewers, welcome to our remote learning lesson in chemistry. In our today's lesson, we shall examine on part 2 of organic chemistry, and that will be the reactions of alkanols and alkanoic acids. Indeed, we shall be looking at the reactions of alkanols and alkanoic acids. Welcome, I am your online teacher, Mr. Steve Getau, on the YouTube channel at Steve Getau 3660. Straight away, I would like us to look at what we shall do. Viewers, we have a flow chart. In this flow chart, we have about 7 steps which will represent individual reactions. And what we will be doing, we shall write the equation that occurs in every case together with the products, and we possibly name the type of reaction and the products that are formed in every reaction. Let's get started. I would like you to note or draw down this kind of a flow chart, and at the end of our lesson, we shall be able to have questions in our live section. Let's get moving. Step number 1. We have ethanol being our representative chemical or representative alcohol. In chemistry, we say alcohol or alkanol, but the two are okay. But this time around, let us refer them to the scientific name alkanol. So we have our alkanol being ethanol. Eth means 2 carbons, and the functional group is the OH. How does ethanol, the representative of the alkanols, react with sodium? Sodium is representing all the highly reactive metals. So you find that in the reaction of ethanol with sodium, be it solid form, this is liquid form, we are going to see sodium being very reactive or more reactive than hydrogen. Displaces, it is able to remove the hydrogen, breaking this bond, and hydrogen is displaced and sodium comes in there, and that way we form the compound with sodium. That compound with 1 oxygen and a sodium, we call it sodium ethoxide. Sodium ethoxide. That is sodium ethoxide, and the hydrogen atom combines with another one to form hydrogen gas. The hydrogen, this hydrogen exists as a diatomic atom. So we are going to balance the equation. Where did the 2 hydrogen come from? So we have to have 2 molecules of ethanol. That gives us a 2 here, and we are able to have the 2, so that we have the account for the 2 sodium atoms. So viewers, let us get to note here that if we had other metals like potassium, then equivalently would form potassium ethoxide. Potassium ethoxide. If we had the alkanol being propanol, then it would be, maybe with the sodium, it would form sodium propoxide. If we had the alcohol or the alkanol being butanol with sodium, then it would be sodium butoxide, and hydrogen. So when you have 1 oxygen attached to the metal and the alkyl here, then we have this kind of the naming. I'm doing this one so that we are able to differentiate this reaction from when we have maybe sodium propanoate, potassium ethanoate, sodium butanoate. This one, or that kind of a case, will be coming up later in our equation there. So let us master that. It is ethoxide and hydrogen gas. That is in step number 1, reaction of alkanols with highly reactive metals. Let's look at step number 2. In step number 2, we are seeing the reaction of an alkanol. This time around, we have taken ethanol as our representative alkanol, reacting with propanoic acid in presence of sulfuric acid, in presence of sulfuric acid. Now, that kind of a process, we call it esterification. The reaction of an alkanol and an alkanoic acid in presence of sulfuric acid, we call it esterification. Esterification. And this is a process whereby an ester is formed. An ester is formed. Let's look at that process. So we are saying that we may start with the propanoic acid. Propanoic acid, the prop means 3 carbons, with one having the carboxylic acid group, or what we call the alkanoic acid functional group, the RCOOH. That reacts with ethanol, that is CH2OH, and this one, if we wish to put the state symbols, they are in liquid form. Now, we are saying that this one should occur in presence of sulfuric acid. Sulfuric acid, and we shall have the product at this point. You find that when this reaction takes place, an ester is formed, and to get the formula of the ester, we may start. Let us start with the alkanoic part. It gives us the CH3, the CH2, and that, and then we link up with the alkanol part, the ethanol part, and we start with this end, CH2, CH3, and you realize that we have 2 hydrogens and 1 oxygen that is coming out, and that is the second product being water. In this case, the formula, we start the formula with the alkanoic part, then the alcohol part, but the naming, and I want to emphasize there that the naming should start with the alkanol part. So this one will be called ethyl propanoid. Ethyl propanoid. This is our ester. The ethyl part, the propanoic acid part. So we have the ester ethyl propanoid, and the other product is basically water. So that is how we go about the process of forming an ester, esterification. Step number 2. Let us move on to step number 3. In our step number 3, which we have here, we find ethanol reacting with an oxidizing agent, acidified potassium manganate. This is just an example of some of the common oxidizing agents. So this process straight away is oxidation. Oxidation. The addition of oxygen to this material, we are referring to that as oxidation, whereby oxygen is added from the manganate ion. What is formed in this case? You find that in this kind of a reaction, we have the ethanol react with or being oxidized by the manganate, presence of sulfuric acid, and the manganate adds oxygen to this, and that releases 2 hydrogen atoms, giving us ethanoic acid and water. 2 hydrogen atoms are displaced by the oxygen, and we form ethanoic acid. Ethanoic acid. Ethanoic acid. Ethanoic acid is a type of a weak acid is a type of a weak acid, and these are the kind of acids that have pH values around 5 and 6. Now, the ethanoic acid is going to react with several other reagents. And why is it an acid? The presence of the hydrogen there, which when it dissolves in water, when it is put in water, it dissociates to give the hydrogen ions, and that gives this chemical compound the acidic properties that we are actually talking about. So we have ethanoic acid, and basically what we are saying is that alkanols are oxidized to their respective alkanoic acids. That means what? If we had propanol, it will be oxidized to propanoic acid. Butanol will be oxidized to butanoic acid. So that is very important, our viewers, that we are able to master that kind of a simple reaction. Let us now see how does this ethanoic acid, the representative of the alkanoic acid, react with several other reagents here. Let's start with the simplest one, a particular metal. We have picked on magnesium. The reason being, magnesium is moderately reactive. We would not like to have the reaction of an acid and a highly reactive element like potassium, because that reaction would be explosive in nature. So we have picked on a magnesium. You may also pick on a metal like zinc. So let's go. We have now the ethanoic acid, that is CH3, like that, reacting with magnesium. In this case, magnesium in solid form. It is important that we realize that this reaction is going to be affected by the valency of the two. The valency of magnesium is a 2, meaning it requires to give out 2 electrons to become stable, while the valency is 1 because it is going to lose hydrogen. 2, the reaction, this kind of a reaction is governed by the position of magnesium and hydrogen in the reactivity series, whereby magnesium is more reactive than hydrogen. So magnesium is going to displace hydrogen from the alkanoic acid here, that is from ethanoic acid. What is going to be formed? We are going to form a salt and water. This is a case of acid and metal. An acid and a metal react to form salt and water. Salt and hydrogen gas, I beg your pardon. So we shall form a salt and hydrogen gas is going to be evolved. So let's look at this. We have the product, and we are saying that in this case the hydrogen is going to be displaced by the magnesium, and what is going to be formed? We are going to form a compound here of magnesium. However, if this has valency 2, then we shall need this to be 2 to obtain the 2 electrons given by this in that kind of a case, and therefore this will release the hydrogen gas. Now, in terms of balancing, therefore, we need to balance this with a 2 to get these 2 and the 2 hydrogens, this with 1 to get the magnesium. What is the name of this compound? What would be the name of this compound? This compound would be called magnesium ethanoate. Viewers, I would like you to note the difference between magnesium ethanoate and possibly if we go back to our earlier work here, whereby we had metal. If this were magnesium, then it would form magnesium ethoxide. Magnesium ethoxide with the 1 oxygen here. So the formula for that would be CH3, CH2O, two of them, and magnesium here. That will be magnesium ethoxide. Having displaced a valence 1 and itself valence 2, then that will be the case. Now let's come to this one, magnesium ethanoate. It has the two oxygens there and itself magnesium. Now that is basically the reaction of an alkanoic acid and a metal. We are saying it will form the respective salt and hydrogen gas. Let's move on to another reaction in terms of ethanoic acid, the representative of the alkanoic acid, and sodium hydroxide. This kind of a reaction is going to involve a particular alkali. Let's not even call it a base. It's an alkali, a soluble base. An alkali here, a soluble base, and an acid. And that is basically a neutralization reaction. That is a neutralization reaction. The type of reaction here is neutralization. Now let's see how is that reaction therefore. So we are having the ethanoic acid CH3 CH2OH plus we are having the ethanoic acid, that is the correct formula would be like that, plus sodium hydroxide. So viewers, this is what we are saying. This is going to represent the acid part, and this is going to represent the alkali. And as we had mentioned earlier, you'll find that sodium being more reactive than hydrogen, sodium displaces hydrogen from this from the acid. And what do we get? We get the compound CH3 COONA plus the hydrogen and the OH combine to form water. So indeed we are talking about this being sodium ethanoate. Sodium ethanoate plus water. This is the salt and the water. So it is also important to notice that in both cases an ethanoate is formed from the reaction that we are having, unlike when we saw the ethoxide. And generally then we can make that conclusion whereby we say an alkanoic acid and an alkali forms a salt and water. So that is simply to say, if this was propanoic acid with potassium hydroxide, then we shall have potassium propanoate. I say that again. If this was propanoic acid and potassium hydroxide, then the salt formed would be potassium propanoate and water. That summarizes the reaction of alkalis and alkanoic acid. Let's move on to step number 6. In step number 6, we are seeing the reaction of ethanoic acid. This one. Ethanoic acid further on react with a carbonate. As we had said earlier, ethanoic acid is basically an acid due to the presence of the hydrogen ions when it dissociates in water. So we are talking about an acid reacting, it's basically an acid reacting with a carbonate. And here we expect that there will be a particular salt plus carbon 4 oxide, some carbon 4 oxide gas, and water. and we shall be able to have water. So let us see how is that reaction. We have ethanoic acid reacting with sodium carbonate. And so what happens is that once more hydrogen is displaced by sodium to form sodium ethanoate plus CO2, that is carbon dioxide, plus water. So all what is left now is for us to do the balancing. If these are two sodiums, they require 2 of this, and we have 2 of that, and we have 1 carbon, 1 carbon. The oxygens are 3 here, and we have 2 plus 1, 3, and I believe now it is balanced. This is can be in liquid form, aqueous. This is a gas, and this is a liquid. So basically, we have summarized the acid reacting with the carbonate to yield sodium ethanoate, and we are saying if this was propanoic acid, with this one then we have sodium propanoate, and so on and so forth. In our reaction number 7, we are going to meet how ethanol undergoes combustion. One thing, it is important to know that ethanol is it is saturated in the sense that when it burns with a pale blue flame, showing that all its carbon to carbon bonds are single bonds. It has no double carbon to carbon bonds or triple bonds. In a saturated hydrocarbon, we have all carbon to carbon bonds being single covalent bonds. And so it burns in air. That is the process of combustion. And viewers, it is important that we are able to differentiate between burning, that is reacting with oxygen, and addition of oxygen to a material, that is oxidation. In this case, we have ethanol react with oxygen gas, and this is going to form carbon dioxide and water, which we can balance as how many carbons do we have in the reactant side? We have 1, 2, so we can put a 2 here. How many hydrogens do we have on the reactant side? We have 3 plus 2 plus 1, that makes 6, so we can put a 3 at that point. And that creates for us oxygens which require to be balanced. On the product side, we have 2 times 2, that is 4, plus 3, that's a total of 7. Here we have 1, so we need to create 6 here by having a 3. 3 times 2 is 6, plus 1, that makes 7, and these ones are 7. So the oxygens are therefore balanced, and that way that equation is balanced, showing that ethanol reacts with oxygen in a combustion reaction to produce CO2, water, and as a senior class here, we know that heat is also produced. In summary, I would like us to appreciate the role in which organic chemistry comes in, and this is an addition to the organic chemistry 1. So viewers, we may expect a question that deals with the combined section, set 1, that is organic chemistry 1, the reaction of alkanes, alkenes, and alkynes, together with alkanols and alkanoic acid in form of a flowchart and the respective products asked, so more so their name. We are confident that with this kind of a revision, you'll be able to go through the topic very well and get the full marks in this particular section. I would invite questions in the live section, and I would also like you to put your comments in the channel. Once more, I would like us to subscribe on this channel so that even other materials that are there, you may be able to have a look at them. I've been your teacher, Mr. Sigwetau, at the channel at Sigwetau, that is 660. Thank you for watching, and God bless you. Part 2 is question time. Let's look at a question involving the reactions of alkanols and alkanoic acids on what we have just learned. This is evaluation time. We evaluate ourselves and see how we have understood on this particular area. The question reads that study the flow diagram below and use it to name the products and type of reaction in each step. So our reactant, central reactant, is propanol, an alkanol. In step 1, it's reacting with potassium metal. This is potassium metal. Potassium metal. We should be able to name product A and B. In step 2, we have the reaction of propanol and ethanoic acid in presence of conch sulfuric acid, conch sulfuric 6 acid, conch sulfuric 6 acid, and some warming. In step 3, we see it, that is propanol, reacting with the oxidizing agent which has been acidified on the basis of some sulfuric acid to give us 2 products. In step number 4, which we have at this point here, we see the reaction of propanol, and in this case we shall change the arrow to move in this direction, and we ask ourselves, what can give us that kind of a reagent? What reagent can lead to formation of propanol, whereby the reagent used is water? What reacts with water to form propanol? What kind of a reaction is that, which we shall have in step number 4? So viewers, let us get going. Step number 1. An alkanol called propanol reacts with potassium to yield 2 products. Which are these 2 products? Kindly write down and play on the video to see the answer. Now, the answer is we should have potassium propoxide. Potassium propoxide, and when the hydrogen is displaced by potassium metal, that's a capital K, then you find that we also get hydrogen gas. Viewers, I would like you to write the equation and confirm with the earlier working. If you look at the question, we are told to name. So we have to write the particular name. So step number 1 is involving an alkanol reacting with highly reactive elements like potassium, and those are the 2 products. Let's move on to step number 2. Step number 2 is involving propanol reacting with ethanoic acid. We agreed that this is called esterification. Whereby this reacts with ethanoic acid in presence of conch sulfuric acid, and we have the first product being an ester and water. What's the name of the ester formed? The name of the ester formed is drawn first from the alkanol, from the alcohol. That will be propyl, and then we have the alkanoid alkanoic part, propyl ethanoate. Propyl ethanoate. That will be the name of the ester formed. And then we shall have product D basically being water. And you can write the equation and that compound. Let us move on to step number 3. In step number 3, we are seeing the oxidation of an alcohol to the respective alkanoic acid, the respective alkanoic acid. In this case, propanol would be oxidized to propanoic acid, and the hydrogen that is going to be removed as the oxygen is added will form water, propanoic acid and water. And then in step number 4, we are actually required to link with organic 1, whereby we see that alkenes, this must be an alkene which has a double bond somewhere, whereby, let me show it like that, a double bond. Into this double bond, we are going to add OH and H. So basically, we are, if we can discuss on this one, we have propene. This is propene. We need to illustrate how this addition of water comes about. So we have hydrogen there. We have the CH3 forming that end there, and to this one we are saying add water. Basically, the water we are adding is the HOH. So if we add hydrogen here, when this double bond breaks, then our compound will be like that, whereby this has the CH3, this part is already this one. The hydrogen will be added here, so we have the hydrogen at this point, and then we have the hydrogen which was already there, the 2 atoms of hydrogen, and then we add the OH at this point. So we are able to see this is CH3, if I may write it down. This is CH2, and this is CH2 with an OH. And this is propanol, what we began with. So step number 4 is actually called hydration. Hydration is the addition of water across such a double bond, and it is facilitated through the breakdown of the double bond to add the OH and the H. That is hydration. So alkenes are hydrated to their respective alkanos. So viewers, this has been a tip of what we are required to do, and I want to believe that we are also able, if we were asked to write the formula of the respective compound, in this case, we will be able to write them down. Let us see how that goes about. If it is sodium propoxide, then we shall have CH3, CH2, COO, potassium. That is potassium propoxide and hydrogen gas. Remember, you are told to name, so we are just looking at the formula to each one of them. In step number 2, we have propanoic acid, so that one would be quite easy. We have that, and water. and water. Propanoic acid and water. From propanol to propanoic acid. In step number 2, we have propyl ethanoate. So that will be what give us the ethanoic acid would come first. So CH2, COO, CH2, CH2, CH3. Viewers, remember we said in the formula, the part of the acid comes first, then the alcohol comes next. But in the name, it is reversed. More or less, we start naming from the name of the alcohol that came in. So we have propyl ethanoate, and then we shall have water. And then from there, we can see the compound here is propene. So viewers, I am encouraging you to do more practice, and should we have any other question, let us meet in the live section for more questions. Thank you for watching, and see you in the live section.